Here we're going to integrate tangent to the power 6 of x times secant to the power 4 of x by using the method of substitution. This approach can be used when either secant has an even power or tangent has an odd power. So what we're going to do is we're going to start by splitting up this secant to the power 4 of x. We're going to split it up into secant squared of x times secant squared of x. The reason I'm doing this is because later I'm going to let u be tangent of x, and the derivative of tangent of x is secant squared of x. So this expression in the parentheses is going to turn into du at the end. However, if we're going to use this method, if I'm going to let u be tangent of x, then I'm going to need to rewrite this secant squared using tangent. So we need to derive a trig identity. We'll derive it by starting with the Pythagorean trig identity, cosine squared plus sine squared equals 1. And all I'm going to do, well, I want to get a secant squared involved, so I'm going to divide both sides by cosine squared, because secant squared is the same as 1 over cosine squared. So I'm going to divide every term by cosine squared. And cosine squared over cosine squared is just 1. Sine squared over cosine squared is tangent squared. And last, 1 over cosine squared is secant squared, which is the reason we use this approach, because now I can replace this secant squared with 1 plus tangent squared of x. In fact, I'll do that right now. We replace secant squared with 1 plus tangent squared of x. And now I'm going to go ahead and start making my substitution. Let's let u equal tangent of x. And that implies that du is secant squared of x times dx. That's because the derivative of tangent is secant squared of x. Now I'll go through and make replacements. Everywhere I see a tangent, I'm going to replace it with u, and then this expression at the end changes to du. So tangent to the 6 turned to u to the 6, tangent squared turned to u squared, and the last part turned into du. Next, I'll just multiply this. I'll distribute this factor of u to the power 6 inside these brackets. And once I do that, I get u to the 6 plus u to the 8. Now we have a simple polynomial to integrate. And its antiderivative is u to the 7 over 7 plus u to the 9 over 9. Last, we're going to replace u with its formula, which is tangent of x. That gives the final expression and our final answer for this integral. So in this particular example, we had a situation where the power of secant was even, and then we ended up letting u equal tangent of x. If the power of secant was odd, then we wouldn't be able to do this. If the power of tangent, however, happened to be odd, then we could do a similar approach, but we would let u be secant of x. And then the idea is very similar.